Hello everyone, welcome back to the fifth video of halogen derivatives. In this video, we will study the chemical properties of haloalkanes. Chemical properties of haloalkanes. Alkyl halides undergo three different types of reactions: substitution reactions, elimination reactions, and reactions with metals. Alkyl halides typically undergo nucleophilic substitution reactions. When a group bonded to a carbon in a substrate is replaced by or substituted by another group to get a product with no change in state of hybridization of that carbon, the reaction is called substitution reaction. We have seen in the previous video that the CX bond in alkyl halides is a polar covalent bond. The carbon of CX bond is positively polarized. The positive charge on the carbon attracts nucleophiles. Now, what is a nucleophile? A nucleophile is a nucleus-loving reagent. That is, a reagent which has affinity for positively charged or electron-deficient centers. A nucleophile is electron-rich species. Thus, in substitution reactions of alkyl halides, a nucleophile is attracted to the positively charged carbon. It substitutes the halogen atom attached to carbon, and hence the substitution reactions are called nucleophilic substitution reactions. The reaction can be represented in a general form like this. The table shows examples of some important nucleophilic substitution reactions of alkyl halides. Practice these reactions by writing the general reaction first, then write example of each of these reactions. Replace R by different alkyl groups such as CH3 methyl group or C2H5 ethyl group, etc. And don't forget to write the names of the reactants and products. Have a look at some examples of nucleophilic substitution reactions. These are a few more examples of nucleophilic substitution reactions. Cyanide ion can attack through carbon or through nitrogen. Such nucleophiles which can attack through more than one sites are called ambident nucleophiles. When an ionic compound KCN reacts with alkyl halide, attack takes place through carbon and alkyl cyanide is formed. But when a covalent compound AgCN reacts with alkyl halide, attack occurs through nitrogen and alkyl isocyanide is formed. Nitrite ion is also an ambident nucleophile which can attack through oxygen or through nitrogen. When it attacks the alkyl halide through oxygen, alkyl nitrites are formed. And when it attacks through nitrogen, nitroalkanes are formed. The second type of reactions are elimination reactions. When alkyl halide having at least one beta hydrogen is boiled with alcoholic solution of potassium hydroxide, it undergoes elimination of hydrogen atom from beta carbon and halogen atom from alpha carbon. This results in the formation of an alkene. The reaction is called beta elimination or 1,2 elimination reaction, as it involves elimination of halogen and a beta hydrogen atom. As hydrogen and halogen is removed in this reaction, it is also known as dehydrohalogenation reaction. The general reaction can be represented like this. Let us see one example. Let us consider alkyl halide as ethyl bromide. So when ethyl bromide is heated with alcoholic KOH, bromine atom from the alpha carbon and hydrogen from adjacent beta carbon atom is eliminated, ethene is formed. Let us consider few more examples. Let us take alkyl halide as isopropyl bromide. In isopropyl bromide, there are 2 beta carbon atoms and hence there are 6 beta hydrogen atoms. But the beta carbon atoms and beta hydrogen atoms are exactly equivalent. So, if hydrogen atom is removed from any one beta carbon atom, the product obtained is same. Thus, the alkene formed is propene. Now, let us consider another example. Let us consider 2-bromobutane as the alkyl halide. In 2-bromobutane, there are 2 beta carbon atoms, but these beta carbon atoms are not equivalent. Beta 1 is a secondary carbon atom, whereas beta 2 is a primary carbon atom. So, if hydrogen atom is removed from beta 1 or beta 2, different products are obtained. If hydrogen atom is removed from beta 2 carbon atom, then but 1-ene is formed as the product. But if beta 1 hydrogen atom is removed, then but 2-ene is formed as the product. The different products of elimination do not form in equal proportion. After studying a number of elimination reactions, Russian chemist Saytzeff formulated an empirical rule which is known as Saytzeff rule. In dehydrohalogenation reactions, the preferred product is that alkene which has the greater number of alkyl groups attached to the doubly bonded carbon atoms. In other words, Saytzeff rule can be stated as more substituted alkene is formed as the major product. In dehydrohalogenation of 2-bromobutane, but 1-ene and but 2-ene are formed as the 2 products. Out of this, but 1-ene is a mono-substituted alkene, whereas but 2-ene is a di-substituted alkene. Thus, but 2-ene is formed as the major product. More highly substituted alkenes are also more stable alkenes. The stability order of alkyl substituted alkenes is tetra-substituted alkene greater than tri-substituted alkene, which is greater than di-substituted alkene, and then mono-substituted alkene. The third type of reactions is reactions with metals. Active metals like sodium, magnesium, cadmium readily combine with alkyl chlorides, bromides and iodides to form compounds in which carbon is directly bonded to a metal. Such compounds are called organometallic compounds. The first reaction under this category is formation of Grignard reagent. Grignard reagent has the general formula RMgX, in which magnesium is directly bonded to a carbon. This Grignard reagent is an organometallic compound. Alkyl halide reacts with magnesium metal in presence of pure and dry ether to form RMgX, that is Grignard reagent. For example, methyl iodide reacts with magnesium in presence of pure dry ether to form methyl magnesium iodide. Similarly, ethyl bromide reacts with magnesium in presence of ether to form ethyl magnesium bromide. Grignard reagents are very reactive compounds. Hence, these reagents are very useful in synthesis of many organic compounds. They react with water or compounds containing hydrogen attached to an electronegative element. For example, reaction of Grignard reagent with methyl alcohol, reaction of Grignard reagent with ammonia and with water. In all the three reactions, the hydrogen, that is a positive part, combines with carbon and forms hydrocarbon. Hence, the reactions of Grignard reagents cannot be carried out in aqueous solution. The second reaction is Wurtz reaction. In this reaction, alkyl halides react with metallic sodium in presence of dry ether to form higher alkanes containing double the number of carbon atoms present in alkyl halide. For example, when ethyl bromide reacts with sodium in presence of dry ether, butane is formed. When a mixture of two different alkyl halides is used, all the three possible alkanes are formed. Hence, this method is not useful for two different alkyl halides, as it results in the formation of different alkanes. For example, when methyl bromide and ethyl bromide react with sodium in presence of dry ether, ethane, propane, and butane are formed as the products. The mixture of three alkanes cannot be easily separated out. Methane cannot be prepared from this method. I hope you have understood the reactions of alkyl halides. I refer to the Maharashtra State Board textbook. I thank all who have helped me in making this video. In the next video, we will discuss optical activity and mechanism of nucleophilic substitution reactions. Until next time, thank you for watching the video.